Hi, welcome you all for the for my video for this video on strain measuring devices. Strain is one of the very important parameter in mechanical engineering. Even during the force measuring devices, one of the force measuring device was based on strain gauge based load cell, which is used as a load measuring or force measuring instrument. So, strain gauge is used for multiple purposes. Even the strain gauge is used to calculate the forces as well. That is, in terms of finally, the output is calibrated in terms of suitable forces or torque. A strain gauge based dynamometers are being used in machine tools to check the forces, cutting forces are developed. So strain gauge plays a very vital role in mechanical engineering in various disciplines or various applications. In the design and construction of machines and structures, it is very necessary to know whether the mechanical components can carry the loads which are demanded on it without any excessive deformation or failure. Hence, the stress and strains plays a very important and vital role. That's why even the stress analysis, for that we need strain gauges. Uh, or even if we go for a similarly, like the strain gauges are being placed below the bridges to know the early failure of the bridges in some cases. So it is not only with respect to the component for that is a force measurement in case of the strain measurement, for simple applications or for the component failure detection, it also be used for the direct application. That's why the strain gauges are very important. Further, stress is defined as the force applied per unit area, where strain is defined as the change in length per unit original length. So the stress cannot be measured directly, and hence generally normally strain which is nothing but the change in dimension per unit original dimension is measured with the help of the strain gauges. So uh, so in simple, when a system of forces or loads act on a body, it undergoes some deformation. The deformation per unit length is known as unit strain or simply a strain or engineering strain. Any strain gauge is a device used to measure the strain on a free surface of a structure. Something like the strain gauges are preeminent tool in stress analysis. As I mentioned already, in stress analysis or in simple experimental stress analysis, always demand for the strain gauges, because based on the strain gauges itself, the strain gauges are the inherent part of this experimental stress analysis. The Coming to the basic principle of operation of this strain gauge is so simple, so because of which it plays a very vital application. It is a device used for measure the dimensional changes on the surface of a structural member under the testers. Further, strain gauges of all types are essentially employed to measure the linear deformation over a given gauge length. The sense the change in length, magnify and indicate in some other form. The strain gauge is invented by uh, Edward E. Simmons and Arthur C. Roach in the year 1938. Further, when a strain is applied to a thin metallic wire, its dimension changes. That is what we know. Yeah, and over the basic law states also. Thus, the change in the metallic wire causes the change in the resistance. Change in the metallic wire changes nothing but the dimensional changes which occurs in the thin metallic wire causes the change in the resistance of the wire also. So it has got a wide range of applications. This is a simple principle being used for the actual applications in wide range of mechanical engineering. It can be used for the measurement of load, force, thrust, pressure, torque, displacement and flow, etc. Further, the effects of all these variables to be measured are first measured by the primary transducers, generally like the bellows, Bourdon tubes or cantilever beams, etc. Later, they can be converted into simple displacement. The displacement is then measured by the strain gauges. The classification of strain gauge. Depending on the principle of operation and construction features, generally strain gauges can be classified as mechanical strain gauges, optical strain gauges, electrical strain gauges. In the electrical strain gauges, again they can be classified as four types: capacitive transducer gauges, inductive gauges, electric gauges, resistance type gauges, and more fringe technique, interferometric based strain gauges, photoelasticity based strain gauges, holograph based strain gauges, and grid method. Based on this uh, for the within the perception of VTU syllabus, the mechanical strain gauge and optical strain gauge are very important, and in the electrical strain gauges, especially resistance strain gauges, are very important. Coming to the first one, mechanical strain gauge. Further in this video, I am going to discuss on the mechanical type of strain gauges, mechanical strain gauge and optical strain gauge. Let us go with the first one, mechanical strain gauge. In the figure you can see it is a mechanical type of strain gauge, which is also we call it as a Berry extensiometer. This type of strain gauges generally involves mechanical means for magnification, because whenever we consider a whole system of measurement, there is a need of input device, intermediate device and output device. So here the gauge points or the plunges points which are placed over the specimen, those are the input devices. A magnifying mechanical lever which actually magnifies the strain, which is or the dimensional change which occurs over the gauge length of a specimen. So here the magnification is being achieved by mechanical means. Extensiometer employs compound lever having high magnifications were being used. It consists of two gauge points. We can observe here there are two gauge points. One is here, the other one. Among these two gauge points, this is being the fixed one, whereas the this one is actually the this one is the actually movable one. So this stationary fixed one or the stationary strain gauge is again placed over the one endpoint of the gauge length. So extensiometer employs compound levers having high magnifications were used. It has got two gauge points which will be seated on a specimen whose strain is to be measured. One gauge point is fixed while the other gauge point is connected to the magnifying lever. Here we can see this another point is connected to the magnifying lever, which in turn is connected to the dial indicator. The lever magnifies the displacement and is indicated directly on the calibrated dial indicator. This displacement is used to calculate the strain value. The most commonly used mechanical strain gauges are Berry type and Hagen-Berry type. The Berry type extensiometers are shown which is shown in this figure. In the figure, the Berry type extensiometer has been shown, which is generally used for structural applications in civil engineering for long gauge lengths up to 200 mm. The advantages of the mechanical strain gauges are like they are self-contained magnification system. They possess a self-contained magnification system, like in this example, a magnifying lever. Further, there is no auxiliary equipment is needed as in case of electrical strain gauges. Like example, if I am operating the electrical strain gauges, obviously I need an aid of electrical source of energy for operation. So, whereas in mechanical strain gauges, no such auxiliary equipments are required. Coming to the limitations, these kind of devices can be used only to the static tests. They cannot be applied to the dynamic tests. Generally, like the tensile testing, compression testing, those are all static tests. So these kind of equipments can be used only for the static tests. The second limitation is about its higher inertia of gauge. Whenever there is a mass mechanical, obviously the higher inertia point will come. Whenever there is a mechanical components are involved, the inertia and friction both are part and parcel of the system. So the higher inertia of the system makes it unsuitable for dynamic measurements and also for the varying strains. The response of the system is very slow, and also there is no method of recording the readings automatically. That is the another important thing, because it needs another operator who need to record the readings and uh, calculate the strains. And one more important limitation is there should be a sufficient surface area on the test specimen, or else we cannot place those 2 points, and clearance above it in order to accommodate the gauge together with its mountings. Next is that is about mechanical strain gauges. Next we'll move to the optical strain gauges. These optical strain gauges are most commonly used type of and the most commonly used optical strain gauges are developed by Tuckerman. Basically, these optical strain gauges are used to measure elongation as well as deflection. They are of two types, like Martin's optical gauge and Tuckerman's optical gauge. Martin's optical gauge is out of your scope. However, I just brief it in the 3 to 4 points, and then I will move to the Tuckerman optical strain gauge. Uh, Martin's optical strain gauge. These are the gauges which employ variety of mirror systems to obtain optical magnification. The well-known optical system used in a strain gauge on a single mirror system is a Martin's optical strain gauge. The pivoted knife edge carries a mirror, and the other end of this arm is fastened to specimen. So as the specimen elongates, the measuring knife edge will rotate about its points, thereby tilting the mirror. The reflection of the illuminated scale in this mirror is viewed through the telescope, and then with the help of the telescope, the reflected image and the original image, the displacement is being calculated. Based on the displacement, the amount of deformation which has occurred in the strain material is being calculated. So that is about the Martin's optical strain gauge. So let us move to the important one, that is Tuckerman optical gauge, which is important for your syllabus. In this instrument, the relative rotation between the fixed mirror and the movable mirror is measured with autocollimator. The autocollimator consists of a lamp source to produce parallel beam of rays and a scale to measure the deflection of the reflected ray. A tungsten carbide rocker or a lozenge acts as a moving knife. One face of this lozenge is polished to act as a mirror. The distance between the fixed knife edge and the lozenge changes due to loading. So then the lozenge rotates, and if any light beam is falling on it, will be deflected. Further, so in other words, if the specimen deforms, rotates the lozenge, here you can see the lozenge, which in turn deflects the incident ray or beam back to the reticle. Actually, three images are visible on the reticle, among which one gives the measurement of strain and other two helps in alignment of the gauges. So the sensitivity of the gauge is about 2 microstrains, and this gauge is always available with a wide range of gauge length about 6 mm. It can measure both static and dynamic strains and cyclic strains up to 180 Hz. The advantages: the position of autocollimators need not to be fixed relative to the extensiometer, and hence reading can be taken by holding the autocollimator in hand. And these are actually best suited for static tests. The reduced wiring as compared to electrical resistance, lightweight compared to others. Limitations: it cannot be used for dynamic tests and varying tests. Large gauge lens are required. It cannot be used where large strain gradients are encountered. So this is about the mechanical strain gauges and optical strain gauges. In the next class, we continue. In the next video, I will continue with the electrical type of strain gauges. Basically, electrical strain gauges. Uh, in electrical strain gauges, the strain or displacement is measured as a function of resistance change. Even there are many more types in the electrical strain gauges, which I will discuss it in the next video. And further, there are important other parameters which contributes in the electrical strain gauges, that also I will discuss in detail about them in the next video. Okay, so and this is just an introduction. uh, these electrical strain gauges, as I mentioned, basically works on the principle of strain resistance change due to the change in the dimensions of a wire because of the induced strain in the material. I hope this video has given you insight into the types of strain gauges and mechanical strain gauge in detail, and optical strain gauge, especially Tuckerman's optical strain gauge, in detail. Uh, I I thank you all. I think I have used many resources and different textbooks in preparing this teaching material. I hope I acknowledge all such sources through this video, and I thank to all of them, and also the others who have helped me in preparing this teaching material. I hope you liked this video. I I thank you all for watching this video. Thank you once again.